Shiva, you're seeing the screen, right?
Yeah, I see the screen.
So you see, this is a class, right? Now, in this, they do something called super. Do you know what is it?
See, it's like this. Class net inherits the module class from NN. You see, NN.module. That is an inheritance.
Okay.
So, NN.module is the parent class. Now, in this case, you're doing an initialization. So, before you initialize the net thing, you want to call the initialization on the parent.
Okay.
So, that's it. So, that's a super.
Okay. Okay, so this is an inheritance.
Exactly.
Okay, I completely forgot. Okay, I receive. Because why I was worrying was, so what happens is here, for instance, they create an instance of this net. And then, when they send an input, you see that net and inputs. And I was like, how does this work? Because in this case, like, this doesn't seem to, in our case, there is no such thing which works. And there's something called forward. And there is no call for forward. And I think now I should look at NN module to see what exactly it is.
So when it's like this, when you say net thing, that is just the initialization.
Yeah.
I mean, in Python, this is all you need. If you're using Java or JavaScript, you will say new, where it's a little explicit. For example, in Java or JavaScript, it will be net is equal to new net parenthesis.
Yeah.
Whereas here it's just net parenthesis.
Yeah. No, I see. Because in here, when there will be something in NN module which essentially takes in inputs and perhaps will call upon this forward function, I guess.
So it's like this. Whenever you're inheriting a class, right, the child class can do two things. For every method in the parent class, it can completely redefine it. So, for example, the net class can have a new init with no reference to the init of nn.module. Okay. So, you're completely creating a new init for yourself. The other possibility is you take all the functionalities of the parent class and add more for yourself, which is usually the best thing because that's what inheritance is all about. So pretty much any class can be done the same. You can completely rewrite it, replace it, or you can just substitute.
Okay. Perfect. Okay. So this I will kind of do away with because otherwise it's fine. I just was not sure what exactly was happening. Now it's more or less clear, and I just have to go and look at what is NN module, and most likely it's a specific type of class where which has a specific structure, and so which is fine. Okay, so we are back to our M5. Okay.
All right. So what had we decided? Okay, we had done categorization. Category. We had then arranged. Yeah, so this is the total revenue, right? So our plan was that for each day, we want to synthesize. Is somebody struggling to come online? I see this thing jumping all the time.
Is it with Shuyash? The one who was there at the start?
Yeah, I think so.
Yeah, and it's also very...
He doesn't seem to speak. So I don't know.
I feel the interface is strange as well because I don't see, for example, the name of Harish.
So supposing when I start talking, will it jump? No. Yeah, kind of weird.
I'm finding to off my camera.
No, that feature has been removed. Actually, I think I will recommend that it should be brought back because it is. You see, the bars are always decreasing very disturbingly. Mine is again. I'm right near the router and still. Look at that, only 3 bars. Anyway, let us try to do our best this time. So,
yeah, it is better to have the screen at the left side. I mean the video one. Because like we are comfortable with the left side. I don't know because if we read from the left to right, right? So if you want to say, like, directly we can go there.
Okay.
That will be better.
Okay. I would say, okay, if there's a feedback session, this place, if there's feedback asked us, you can just add these to it. Otherwise, I'll just message him about it.
Yeah.
Okay.
Yeah, and also, I will send you this screenshot as well, where
Yeah.
I find it difficult to see the name. For instance, the full screen does not let me see the name of the third participant, for instance, because the under bar that they have is essentially on top of the third person's name. So. And I share the screen, so I will send you the screenshots.
Okay.
Okay. Let's go. So I think what we were trying to do was we had these categories in place, and we thought we will try and predict what is happening with respect to the categories. So whether it is how are they being sold. And this one is on the revenue. I think we were also doing something with.
So it's like this. We want for every day. The idea. I mean, we thought initially that we'll do a linear regression to be simple. We can do recursive neural networks and all that, but for now, let's do it like just simple. We have to slowly start exploring this thing because that requires some amount of reading. So, if we use a simple linear regression, we need an equation of y is equal to c plus m1 x1 plus m2 x2 and so on and so forth, right? So the y is what we want to predict, right? So now from our challenge, the y is what is it? The number of items sold, the revenue. How would you like to do it?
I would say the revenue is better because we would then be able to use selling prices as well as a measure, because I think revenue or number of items sold won't make a difference, but revenue might be interesting because then the selling prices effect might be visible more pronounced.
Actually, no. Now, come to think of it, we would need to find because it's like this. We have this data for 1936 or 41 days. We will be given for the next 20, if we are given for the last 28 days, the selling prices, they want us to find out what the revenue will be. Which means that for those selling prices, they want how many items are sold. And according to the items and the selling price, they will know the revenue.
Yeah. Okay.
So we do have to calculate so essentially it's like this. For every day, we have the several inputs. One input is, of course, the selling price. Another input can be the day of the week. Another input can be the type of item. What else can you think of?
Okay, so selling price, what is the special day on that day? Something to do with, like if it was, for instance, if it is a food item, it is very likely if it's snap day, then there will be more food items sold.
Okay, so that means snap day. So we can have whether it's a snap day or not a snap day.
Yeah.
We can also look for whether it is a weekend or not. So whether it's Friday, Saturday, Sunday.
Yes.
Right?
Yes.
So we can have like 0 for a weekday, 1 for a weekend.
Yeah. I'm assuming that. Let's keep it that way because I think it's in the US. So weekday, weekend would be a distinct thing, because in France or Europe, typically Sundays you may not have as much state sales due to many shops being closed on Sundays.
Yeah, Europe is different. Sunday in the US, Canada, almost everything is open for at least a moment of time.
Yeah. Okay, so then we will keep it that way. There's Saturday, because in I would say in Europe, then Friday evenings become more important because a lot of people do purchase Friday. But anyway, so in this case, we will keep the weekends, weekdays separately, and also the events on if there is an event, Christmas or something like that. We can probably talk about that being useful to predict some non-food items, because we might have more to do with hobbies, I would say. So you have household you can remove, and you may not consider that household and food will be influenced by this, but very likely hobbies will get influenced. But the only thing is that it is very likely that there will be sort of a non-causal effect, because if you have Christmas coming, there will be more purchase a week before or 2-3 days before, and not on that day or the day after. So most of these cultural events that we are talking about, so the events are a bit weird because of that. Because some events you might say that the purchases will happen on that day. Like for instance, you have this Super Bowl event where you are likely to have an effect of on that day, because people will buy a lot of stuff and go and sit at home and buy to sit together and watch the match or whatever. And then you have on the other side where events like Christmas, where people are going to purchase a lot a week before. I mean, that is a period where a lot of things will happen. So I'm a little conflicted of how to use the events, because there is definitely a non-causal effect, or at least like it's more than it being influential after the event. It's actually going to be influential before the event actually happens. So I don't know. Maybe we'll have to use let's say data from 4 days in advance when it comes to we can probably see, because we love to develop a non-causal model in this case.
Okay. So what do you mean? No. What I'm thinking, the problem is things like games are tough to actually do, but we could pick out the holiday calendar in the US. And there won't be that much. We're talking about Easter, we're talking about Thanksgiving, we're talking about Christmas and a few others maybe. Because Europe doesn't have that much holiday. US doesn't have that much holidays anyway. So, if we just have these, then we just have to have an event that happens, let's say, 10 days before that.
Okay.
So, we can classify another event. Let's say we have 0 for no event, normal day, 1 for snap event, 2 for a major cultural event, on 3 for like some other stupid event, like, game or something like that.
Okay.
But then again, the third we can always see if it goes to that level. First we can just stick to 0, 1, and then we can add 2.
Okay, I see. Now, because that's a good idea. Or simply we would just say T-7 there is an event. The event happens on T-7.
No, the problem is this: we need to provide so many x variables to be able to calculate the coefficients. So we need to classify for every date. So if let's say the 26th is a cultural event, then we have to say that for 10 days or let's say 8 days, whatever, 7 days, before that, the days will all have a tag that this day is tagged as a cultural event.
Yes, okay. You can do that, yes.
Yeah. So therefore, for every day we have this equation fitting. So we'll be fitting this equation for 1936 days with all these coefficients. So let's say X1 is the selling price, X2 is the event on the day, X3 is whether it's a weekend or not, right? What else can we think of? And we can also think for the particular thing whether there is, let's say, a food stamp or not.
Yeah.
That's it.
Snap event.
Snap event. So I would say snap event we can actually separate it, because snap event is something which is more economic, like it is like a food stamp or something of that sort.
Yeah.
So we have four X
variables. Has influence only on that day. So
on which day?
On that particular day where the snap event happens.
No, it's like this. Snap event could also be for various reasons. Like for example, what happens, I mean this happens even in Europe, right? You get these local newspapers where they give you coupons, right? And sometimes they'll just say that this coupon, like on so and so date, you can just redeem it and get so much off. So that could be a snap event.
Yeah.
Right.
Yes. But the only thing is that what I meant was that the snap event influence is only on that day, whereas cultural event influence happens as we will transport it to be for a few days. So we probably then have to go back. I think maybe we want to do a basic influence analysis of the different events, whether they are happening or not on that particular day, and whether there is how does the sales change for these various categories. So for instance, what we have now is we have these items, like the revenue says for food, one, hobbies, households. So what we can do now is I will check what is there in the original EF.
Basically what we have to do is we have to do a correlation. We have to do a correlation between different variables.
Yeah, exactly.
So what I would suggest is, like here we have all the food items as indices, right? In this thing. What we can do is we can now add another index to it. So it will be a multi-layered index. First index is the name of the item. Second index will be the subcategory. So we can have selling price. We can have we can have the revenue, item sold, revenue. We can then have the next one. What is it called? We can classify each day. So we can again find out with respect to that day. We can do the classification. So either we can have whether it's an event, no event, whether there is a snap coupon, no snap coupon, all those things. So there will be a multi-layered index, right? It will be a multi-layered index with food items, and let's say for each food item there will be 4 rows, sub rows on each day.
Okay.
So depending, for example, some things will just be like, will just be like date, like weekend, everything. That will just be for that day itself. There are some things for the item, like whether it's a snap event. Now those snap events, are they for the item or are they for the day?
Day.
For the day. Then that's great. So that means we also have separated whether a particular classification of item has on that day a snap event or not, which means a lot of it is dependent on day. We now have pretty much a time series kind of analysis. Of course, segregated between different events, different types of categories.
Yeah. Okay. So do you let me just what is the I just wanted to see what are the things that are there. Forgot completely. Okay, it's calendar here. So the calendar, if you look at it, has two different types of events, but anyway, that is there for us. So in fact, long back I was actually doing some analysis saying that there were different types of events, and I was trying to categorize them. So for instance, we have cultural, religious, sporting, and national. So typically if it's cultural and to some extent religious events, because I think religious, I would say, categorize only Hanukkah maybe, and then maybe Easter, because the rest are not really much of maybe Orthodox Christmas, much of religious fervor to it. Maybe it is there, but Christmas, for instance, is mostly non-religious with respect to how people are going to buy stuff. Anyway, so this is one thing we can do. It is something like this. We can create a category of.
No, actually, you know where the challenge is going to lie. The challenge is going to lie that we can do, if you go up to the previous data frame where you were showing this. So this is the data frame, the calendar DF, right? So we have what we have done. Remember what we've done? We did a pivot table. What was it that we did? We did a merge and then we did a pivot, right?
Yeah.
So now what we have, if you look at the day, we have all the days here, right? Is this, I don't remember, we've done all kinds. Can you go back to the original calendar DF?
What do you mean original? Okay.
Or is this like, is there one? Yeah.
This is the one.
Okay, this is the same. So now if you look at this, this has an index of 0, 1, 2, 3 and all this, right? Then there are dates, month here. So now what we are trying to do? What we are trying to do is this. We have, if you look, the categorization of the days. So if you look, weekday, W day, right? So if we categorize, so which means it is 1, 2, 3, 4, 5, 6. So it starts from 1, goes up to 6. Can you check calendar DF head 10? Because it's...
Yeah, it is 1, 2, 3, 4, 5, 6, 7, yes.
Okay, fine. So which means that in our case, one is, you can just go back. Yeah. So in our case, what we have to see is, let's say for example, we have the column D, right? This column D is actually corresponding to all the columns of the latest matrix, latest data frame, right? Now we have to do a similar kind of flip like what we did before, right? So
okay. In what sense?
Yeah, again, this is like, I don't know if I'm using the right terminology. Can you just copy this calendar DF and bring it down? We'll play around with it. It's easier to like actually type out commands.
Yeah, it is here.
Yeah. Okay.
Oops. Sorry, it's cal underscore DF.
Okay. Can you give me 10? Head 10. Okay, great. So now if you look, we have all these columns of D, right? We have the D column. What we want to do, we want to do a pivot, right? We want to take this column D, arrange the values of that column D as columns on our next new data frame, right?
Yeah.
For each of these columns, we want to assign a few variables, right? Most of our variables are time series variables. So for example, one, we need to find out whether it is a snap event, snap CA, right? So snap CA will be one of them. The next one will be, we want, whether it's a weekday or not. So now for example, to know whether it's a weekday, we need to know if it is a Friday, Saturday or Sunday, which means, is it less than 2 or is it equal to 7, right? Because if you see Friday 7, if that is the case, then it's a 1. It is, you can say it's a 1, otherwise it's a 0, right? So this is the second one. So these will be our indices. So you're now taking a new data frame where all the D values, days are on the columns. The indices are new ones. One index will be the snap event. Second index will be the whether it's the weekday or not. So we can actually start with just the weekday and then we'll actually replace the value. We can do that.
Okay.
The third one, what else did I think about?
It's the event.
It's the event. So here in the event is, for example, what we can try to do. First, if you want, we can take all these three, that is event name, event type, everything, and just put them together and then we'll crunch them. So what we're going to do is this. We're going to do a pivot table. So first we just do one value, then we'll add the rest. Okay. So again, pd.pivot table, we'll need help. Pivot table is always a little tricky. So you have to do it once, twice before you get any sensible values.
Yeah.
So data will be our calendar dir.
Okay.
Okay. Now continue, shift table. Now columns, right? The column will be only one, that is the d value. So columns is equal to d as a string.
D or WD?
No, dd, because we want all the columns to be spread out.
Okay.
Right? Now the next one is we need the index. So if you go down, the index. What will be the index? Let's start with one value. So let's just say our index is wday. Okay. Then the next one is values. Value will be
just a second. Values is column to aggregate and optional.
I think here in this case, not sure, but I think the column we'll have to create. Then in that case we have only one option. So then in that case, the column we don't need supposing we remove the index, and we replace that with columns. So we don't actually specify index, but we specify columns because we want the weekday, right? No, I mean that can remain. No, columns can remain. Columns can remain as it is. Instead of index, we say values.
Values, okay. You want to see how it works?
Yeah, that's it. Just play around with it. So, you see what I'm saying? This is what we've got. Okay? So, I kind of I'm trying to sort of beat this into like a pulp somehow. Okay?
Okay, I see.
Data science at its brutal form. Okay? So, now, if the problem is this, you see the problem is I cannot, if I give index values, if I say index and values, can I create multiple values? For example, now here this is what I'm thinking. Now let's try this again. You can copy that command, put it in the next line, and let's compare. So here what I say is index is equal to this thing, and values is also equal to this. So we should get back the same thing, because here what happens if there's only one, then, it is not.
No, it won't come because, see, index will be, it is trying to put the wday as index. For instance, if I do this, I remove this, because it has to be something which is, so if I do this, it will be fine. Like what you get is wday. And it's now, there will be some sort of an aggregation that we have not done.
Okay. No. Then in that case, we cannot specify an index. You know why? Because we want each of these values as this. So we have to create separate data frames. There's no other way.
Yes. There's
so,
no way, we cannot specify index here.
So what I would say, let's go and create the line 119 or 118, whichever it is. We specify that as one data frame.
This one, right?
Yeah. We could, I'm just thinking, can we use first we'll do it and then we'll try to write a for loop or something. Maybe we can actually simplify this with a for loop. So, if for example, now next, let's try this. Instead of values is equal to wday, let's go to the next one. The next one, what we want is snapca.
So you want this to be put in a specific
You can get rid of that 120 because we don't really. There's nothing we can do with it. Or if you want to keep it as a reference, you can keep it as a, that's okay. But we're not going to use it.
Yeah, let it be.
Okay.
It's fine. It's not. It's just a. I'm not storing any data, so it's okay. Yes. Sorry.
Yeah, so you can start naming all of them. You can name the previous one also. So you can name it like calendar DF part 1, part 2, part 3, like that. You know.
Yeah. Okay. Part. Okay. Okay. Then you want
yeah.
To put this events you want?
Snap CA.
I'm sorry?
Snap CA.
Snap CA, okay, yeah.
What is like direct, we'll just do it, yeah, so Snap CA. Okay, very good. So now, the next one we have is, supposing for example, we have to now, what do you want to do next? You want to handle the events or you want to handle the weekend?
So weekend, you just have to change it, right?
Yeah, that's it. That's it.
So you can actually do, for instance, a small. We can do an apply function.
Exactly.
So let's say there.
Yeah. Okay. You can do it.
Then let's see. And we can apply
actually there's a problem
individually.
You know the problem here is that you have to apply it along the columns.
You can apply along. Okay, you can't apply along the rows.
No, there's a simpler way to do that. You can just write a query.
What?
We can do a query.
Shiva, your voice is going down.
Yeah, because this thing is down. Okay, is it better? I see very low bars on this thing.
Okay, fine.
Okay.
It's going up and down.
Yeah, I'm as close as possible to the router now. What to do?
Okay, that's fine.
Okay.
No, your video is fine. It's just the voice is going up and down.
Yeah, I think the video is sucking everything out.
Okay, maybe it's my problem. Anyway, let's see.
Okay. So what I would say is, what I'm thinking is, for example, I'm just thinking, so it's like, how do we do this? Okay. Then what we have to do is, we have to then do this query, we have to do this on the actual main data frame first, and then do a pivot on that. So we create another column.
That's a lot easier.
Yeah.
Exactly. So what I'll do then is, okay, let's say,
so you can just,
copy.
Oh no, you can just add another column to it, weekend.
No, but I want to keep the original separate.
Okay.
That's the only thing that I have. Copy and then add a. Okay, I'll now write a function.
Though it might be possible to do it as a lambda.
I'm sorry?
It might be possible to do this as a lambda, because if lambda x, then in that case you have to say 0 if x is greater than 2 and x is less and x is less than 7. Else this thing 1.
Yeah. You want Friday also to be counted as a weekend?
Yeah, Friday usually is there. Friday evening it starts.
Okay. So, yeah. I mean, you can put it the other way around as well. Weekdays. Okay. Weekend is 1. Okay. And then you want to keep it as a lambda. We can also try that.
Yeah.
Okay. So, let me say here copy WD code equal to PF code.
X lambda x first.
I'm sorry?
You just say always lambda x colon. Then first we have to do the first one, that is 1. So first will be the return value. No, first it will be 1 if, then that thing x is less than equal to 2 or x is less than equal to 7, else 0.
Okay. Okay.
And try it out.
Let's see.
Again, do head 10 or 20, whatever.
Yeah.
Hmm.
So it's 1, 1. It's fine.
Yep.
1, 2, 3, 4 days, which is not. Yeah.
Yep.
That's fine. So now you want. I will go back here and to part 1 again, but this time I would say.
Yep. It will be weekday coded.
Underscore copy and underscore code. Okay. So now if you can see.
Oh, you lost part 1.
Yeah.
This is also. I thought there was already a part 1.
Yeah, but I put it on top of part 1.
Okay.
Because that was weekdays.
Okay.
That's redundant.
Okay, fine. Okay, then that's okay. So this is our new one. That's done. So we have, what all we have? We have snap CA and we have big decoded. Now, what else do we need? Event.
Events we can actually do, for instance, we already have done that. I think it is there, for instance, CA1, I do. It's there, events is there. So we can actually take it from there if at all you want it.
Yeah, same thing. The only thing here you will have to do, again, you will have to do an apply on the day, add a D underscore. Just to make it like uniform. Because you see the last column day, the D has been removed, D underscore.
Yeah, I see what you mean. Just a second. I think there is one where we have it already done. Yeah, it's.
You can do that. It's a very quick thing. Again, lambda.
Yeah. Okay. Okay. So.
You can just call it new day or something. Column.
Okay, I will just do a copy. No, it's okay.
Yeah, it's actually a minor thing. If you're adding a new column, it's okay.
Yeah.
Day. Then apply. X, lambda X. Basically, it's here. All you have to say is string D underscore. No, I mean, it's D underscore as string.
What?
You have to say D underscore. So this is as a string. No. The D underscore will be in a string. And then say plus strx. Basically, you are returning D underscore plus this thing. There.
Yeah.
Okay, try it out. No,
sorry. Yeah, that's fine.
So now you can just do again a pivot on this. D with D. Events.
I'm sorry, yeah.
So we now have 3 different data frames, right?
Yeah.
So what we can do, we can create one data frame where we can just add all these 3. So we can sort of create one data frame where we can concatenate all 3. That's what we do. We do a concatenation.
Okay.
I think we'll have time just for that, so we can just do that and conclude. Then we can continue with the next one later.
Okay.
So yeah, try concat. Is it? Yeah. Is it there? Shift tab. Yeah. Good. So now join outer level means, okay. Now axis is equal to 0. So you see axis is equal to 0 means along the rows. Okay.
So you see this one is AB, ACD, and then if I want S1, S2, it will be put like this.
See, so S1 is basically 0 and 1, right? 0 and 1 has the index by default. A and B is the data. 0, 1 again is the index for S2. C and D is the data. Since axis is not specified, it is 0 by default. So which means it's adding the second index, the second 2, that means 2 separate indices after the first 2 indices. Right? Yeah. And this is exactly what, this is all we want.
Yeah.
Right. So you can say, we can do CalDF part 1, part 2. I don't know how many you can add. I think we can add 2 or 1. Yeah. Part 2. So we might have to do this like 2-3 times. It's okay. And it's part 1 and part 2. Huh? Just one. You've written part 1 and part 2.
Yeah, I see. Oops.
Must be
couple of subjects.
Okay, can you again just show me the help of that? Okay. What else could be? Has to be an iter. Can you just scroll? Its axis is equal to this. Okay, so look here what it says. Union data frame or series.
Just a second, we'll go to the examples again. There are some other examples. Ignore index is
you see what has happened? Okay, no. You see what has happened? You have to specify it as a series, as a list. S1, S2 is a list.
Yes, okay. Yeah.
Great.
Yeah.
So this, now we have pretty much what we need. All we have to do is now add to this the item, this thing. We will be sort of merging this to the other one as a separate second level index. We'll be adding another index for each and every item, the selling price on each day, the revenue.
Yeah.
So this is our complete data frame with which we can do linear regression. Y is equal to mx plus c.
Yeah. So okay. Yes. So this one. So for this, for instance, on this very day, we can actually write down, for instance, what else do we think we can use? No, not else, not much. So we can probably consider, now we'll have to look at Y. I mean, the selling prices also we can do, right?
Yeah, selling price is important because we want to see that according to the selling price.
Put them together.
Yeah. So it will be like a multi. Basically, it will be like this. Let's say food 1. Okay, that's one of the items. For that, there will be the mean price in that category, right? Plus all these for each day. That is whether it's a snap event or all these. Then there will be the number of items sold, revenue.
Yeah.
So with this, we can now do a fitting for each and every day for each and every item.
You want to do each and every item, or you want to do?
We'll have to do, again, that we'll have to look. I think we might have to do like a kind of an averaging, or we'll have to again structure that as separate. What do you call? Because they are separate categories.
What will happen is, if we do an each and every item, Sava, we can do it. Because
actually it'll be every category of item, though not every item, category.
We can do it by category. Yes.
Yeah.
Okay.
So then we have 4 into, I think, how many? 6 categories. So we'll have 24 variables altogether. I mean, something like that.
Yeah.
And so that comes to 24 variables over 1936 data points.
Yeah.
Okay, I think we've run out of time anyway. We've been talking for a long time. Anything from you, Harish?
In the pivot thing, can we do more values like we have given the each item?
I mean, that's the thing. Can you think of any? That's what we were kind of brainstorming about it. Like, what else can we add which is a characteristic either of that day or of the food of the item?
What I was asking is that events these values are the right values where we have
okay, that way. You're talking about the syntax, okay? So what happened, what we saw is this. If we wanted more rows, right, and we tried to specify that as a separate index, then it listed all the values of that index as separate rows, which is not what we wanted.
Yeah, I understood. But this values, if we keep 2-3 variables, then
no, then what happens, I think it will sort of do a mean if you don't specify. It does an aggregate function. I mean, we could try that.
Yeah, what I was saying is that event, snap TA,
you can try that. Just copy that and
try that.
Yeah.
I mean,
just copy the entire thing and we just replace it with a list. Values is equal to a list.
Not 3. It's actually with here because they are in different tables. So we'll try to do it 2.
Yeah.
Yeah, it's coming.
Very good. So that means it kind of figures out if they are separate values or not.
Yeah, I mean, look, what is happening is it is just saying that, look, I'm just going to pivot the entire thing on top based on this column that you have given.
So you know,
okay. The sizes are the same. It is able to do it.
No, you know what? If there are 2 values for the same column, then it will do a mean, because basically it sees only, for example, in this data frame, even if it's an index, let's say snapc is an index, or let's say wday coded is an index, like there can be multiple of them, right? So which means that for the same day you could have 2 different values. In that case, it will do a mean. But in our case, we know that that's not the case.
Yeah.
Okay, so this is a simpler way to do it. Good thing that we tried.
Yeah. Can you please repeat the drawbacks of this?
No, there's no drawback. The drawback, if any, is that if for the same value, and this is not really a drawback, this would happen even if we use a single value. That is, if let's say for D1, there were 2 values of snap CA. So there was 1, 0 and there was 1. Right? In that case, it will do an aggregate function because it needs a single value.
So if you look at here, there is something called aggregate function, which is by default mean. Now, so essentially, when we does a pivot table, it does some analysis of whatever contents are there in these values.
Yeah. If there are multiple values, Alright.
Multiply this out will be, for example, like 0, 1 means 0, 1 or.
So it is like this. See, what it does is, it is taking pivot table means it takes the columns and it arranges it along the columns, right? So basically this columns that we specified is one of the columns of the data frame. It takes all the values of that, arranges it, right? Now for each column, it sees if what are the values which are there in the values thing we specified, right? If there are multiple values for the same column, right, D1, then in that case, it will do an aggregate because it has to present only one value, an aggregate function. So that means it will take the mean. So you might see a 0.5.
So I will just do a very simple change in CalDF copy to illustrate that. I would say that, for instance, let's say D 3. What will be that? So it's D4, right? So what I'm going to do is I will just say it's D3. Okay. Now, if I look at it, there are two D3s here. Okay, and the snap CA is 0 here, it's 1 here. So if I do this now, it should be, it is already turned it into a 1.0. You see that there is you can see that the difference between this and this. It's already doing that. I just have to see D3. I'll have to check where it is. I'll just check that. So I'm going to say D_3. You see that this is snap CA is 0.5. So that is exactly because we did not look at the mean being applied because there was no reason to do it. Anyway, this is what is.
In this case we were sure because this is specifically a time series data frame. The data frame is about calendar. There they had said that for all these days this is how they had coded it. Like there was a week ID, there was like what is the actual date, things like that.
Okay. Yes. Perfect. Okay.
Okay, great. Okay, guys, I think it was a good one. So anyway, we're getting closer to our linear regression model. Okay then, so thank you so much coming. Good luck with your move to your new apartment, Arish.
Yeah.
Okay. Take care then. Bye everyone. See you next week.